Hello, today we're going to look at how you set up the multimeters. So here's your image. So this one I'm going to set up as an ohmmeter, this one I'm going to set up as an ammeter, this one I'm going to set up as a voltmeter. Alright, and the connections on this diagram show you where you need to make your connections. Alright, and you can see that everyone is always connected to the COM. So what I need is some more wires. Firstly, you always need to make sure that you've got one wire in the COM. So I'll do that first. So here's my wire in the COM for my ammeter. Here's my wire in the COM for my voltmeter. Right, this one's already done. So this is for my ohmmeter. I've set it up in the ohms slot. My ammeter, I need to set it up in the 10A slot, and my voltmeter, which isn't very in focus, that needs to be the same as the ohmmeter, and that needs to be connected to my voltage slot there. The next thing that's different is the buttons that I turn them on to. If I'm turning it to an ohmmeter, I need to look for the ohm sign. So I turn that round there till I get to the ohm sign. That will give me a reading. For my ammeter, I'm not sure that's pushed in, that one needs to be pushed out. Now you've got two A buttons. This is for alternating current, which we won't be dealing with, that gives you a squiggle, and the flat line is for DC, and that's what we will be using. Alright, so that's my ammeter set up. My last one is my voltmeter. Just move those along. And my voltmeter, similar with my ammeter, I've got a straight line with the dots underneath, and I've got a squiggly line. And for your voltmeter, you need to set that up to the V with a straight line. So you can see that I've got ohms here, amps here, and volts here. So now we're going to use the ohmmeter. So you can see in the image, we've connected it to the ohm symbol. We've got one in the V and ohm symbol, one in the COM, the common terminal, and we've got three lamps: 1.5 volt lamp, 2.5 volt lamp, and a 4.5 volt lamp. What I'm going to do is see if there's any difference in the resistance of these lamps. So I'm going to put my multimeter across here and get a reading. We can see that the reading is 2.3, 2.4. Ignore this 0, it's because it has to display 3 digits. So that's, you wouldn't put 10 as 0, 1, 0, so it's 2.3 ohms for the 1.5 volt bulb. If you find that you're not getting the right result that you expect, just do a bit of changing things around. That looks better. Giving me a totally different result this time. So 4.5 is giving me 1.8 ohms. Let's go back and try that now. A 2.5 is giving me a 12.4 ohms, and the 1.5 is giving me 2.3 ohms. So here's my voltmeter setup as we had before. There's the image, and one of the things that is really useful for a voltmeter, and something you could do at home, these multimeters are quite cheap if you want to get one, is you can check about the voltage of your cells. It tells you that they should be 1.5 volts. Here we go. Okay, so 1.5 volts. Our new cell should actually give you a little bit more than that. So we can see. So if I connect that across the two terminals like it's shown in here, okay, I get 1.5, so that's okay. Here's another one that I tried to light my bulb on. So that's 1.4, looks a bit flat. And that one here, I think it's used up its energy. That should be not too bad. Right, so how you would do that if you had a multimeter at home, you get wires with this. You can just take a cell. Again, it's a AAA. AAA should have a voltage of 1.5 volts. Right, so if I clock that across here, again that should go to the positive, the red should go to the negative, and I push it in there, 1.5. Okay, so although it reads 1.05, that is not going to be much good in most of your appliances. So there we've got one that needs to go to the tip. What about using a voltmeter in the circuit? Well, I could show you a simple circuit, the simplest we can do, going back to our torch. So a lamp and a cell, my light bulb lights, and I can take 2 readings with my voltmeter. I can just put the connections across the cell. Try not to wiggle your wires, but that's quite hard on the camera. So I connect my wires into there, and that's working this time that I'm getting a negative, because my COM should be connected to the negative. I can swap that over, so that this is telling me that the cell is providing 1.49 joules of energy to every coulomb of charge. So let's try and see what the lamp is using. So if I connect that across there, ooh, amazingly, this is using 1.495 joules of energy for every coulomb of charge. So that's how you'd use a voltmeter. Now, using the ammeter is actually the hardest one, because we've got the circuit made up already, and you can see by this picture that if we want to use an ammeter, we actually have to break into the circuit, because the ammeter has to be part of the circuit. When you're using it in the circuit, you actually only want one, and I recommend you getting a short one. What we're going to do is we're going to break into the circuit here. So we've got to pull apart our circuit. That's the one we use just out of voltage. So I'm pulling that apart. I'm going to put that wire into my 10A, and then I'm putting my wire from my COM into the negative, and that tells me that the current is tiny 0.095. Right, I can then pull that one out, put this circuit back, and then I could actually break into this side of the circuit and see, well, what's the current on this side of the circuit? So here it's going to be my negative end there, and that's going to be the positive end there. Again, if you get the negative, just change it, and when I connect it to this side of the circuit, phew, I get exactly the same current. So now you should be familiar with setting up an ammeter, a voltmeter and an ohmmeter. One thing I forgot to say about an ohmmeter is it's really good for testing to see whether your wires have got a break in them. So if we just take one wire, connect one end in the COM, one end in the ohms, the resistance of the wire should be just about nothing. If you find when you wiggle this it starts coming up with a number, you've probably got a very loose connection. I've been trying to find a dodgy wire, and believe it or not, when you want one you can't find them. When you don't want one you find plenty. These are 2 good wires. So while I was trying to find the dodgy wire, I suddenly thought, well, we should try and find what's the resistance of the wire that I made in one of the videos. So I'm going to connect this up. So we know that each of these wires had a resistance of 0. So if I connect those, notice it doesn't matter which one goes in the COM because there's no power supply, there's no polarity. So if I stick that, these are crocodile clips, or I think it's funny the Americans call them alligator clips. My wire there that I made also has a resistance of 0 ohms, so that was a pretty good wire that I made. And let's try this one. This is a flatter, longer one. So let's see what the resistance of this one is. Obviously you want wires to have very little resistance, that's the whole point. So Mrs. Hargreaves' homemade wires were pretty good. Might be something for putting on your Christmas present list, is a multimeter, very useful.